Bom dia, sejam bem-vindos ao Webinário Risco de Compliance e Segurança no Uso de Open Source, promovido pela Nova 8, Cybersecurity e Whitesource. Next slide, please. Meu nome é Wilson Bejar, eu sou consultor técnico da Nova 8. Eu e a AD estaremos hoje dando suporte a vocês durante a apresentação, através da opção do chat no painel de controle. Antes de iniciar o webinar, eu gostaria de passar algumas informações sobre o evento. O webinar está sendo gravado e todos os participantes receberão um e-mail com os links de gravação e cópia da apresentação que estarão disponíveis 24 horas depois de encerrado o webinar. O webinar será apresentado em inglês e todos os slides estarão em português. As perguntas poderão ser efetuadas no chat, localizado no painel de controle. Fiquem à vontade para fazê-las tanto em inglês quanto em português. Se forem feitas em português, nós faremos a tradução para o inglês e passaremos para o speaker. As perguntas serão respondidas na sessão, ao final, na sessão de perguntas e respostas. No final também eu vou comentar sobre um template de autoavaliação de risco no open source que foi criado pela Nova 8. Next slide, please. É com grande prazer que apresento o nosso palestrante de hoje, é o Jameson Raymond. Ele tem mais de 20 anos de experiência, né, na área de segurança, redes, auditoria e compliance, e ele é diretor de engenharia e soluções da Whitesource. Então, acho que vamos iniciar a apresentação. So, welcome, Jason. Please, the stage is yours.
Thank you, Wilson, and thanks everyone for joining us today. Today's presentation will cover the following primary topics. We will talk about the business opportunities that are presented to companies that use open source software as part of their software applications. We'll talk about the management of open source licenses associated with open source libraries in your applications, and we'll talk about the management of open source software vulnerabilities and security vulnerabilities in the open source libraries. Let's start by talking about how using open source software can enable your business to meet your business objectives. The fact of the matter is, you simply can't develop software at today's pace without using open source software. It really has become a necessity. Some of the largest businesses in the world have an open source first strategy for developing applications. Right? They always want to use open source software to present the features that they want in their applications before they look to write those features themselves. Companies such as IBM, SAP, GE, Comcast, Optum, and others are using open source whenever they can. Open source enables companies to build better products faster. After all, why should you reinvent the wheel when you can just download the wheel from GitHub? As a result, the use of open source software used by companies is growing. Whitesource Software's analysis shows that 60 to 80% of an average application's code base is actually comprised of open source software. So let's discuss some of the biggest benefits businesses experience by using open source software. The first one is innovation. Using open source software fosters innovation. It enables companies to take advantage of the experiences of a diverse and broad set of developers across a variety of industries and disciplines. It also enables companies to take advantage of different approaches to business requirements that may not have been considered by the developers in their own organization. The second benefit is agility. When 80% of your code is coming from open source libraries, then that means you only have to write 20% of the code. And as a result, your release cycles can speed up and you can respond to business demands more quickly and agilely. Right? You'll be able to introduce new features as required more efficiently and quickly. The third benefit is a culture shift in support of digital innovation. Using open source shifts culture because it encourages collaboration, contribution, and responsibility from the users of open source. It requires you as a consumer of open source to participate in the development and maintenance of the open source software you use. When you use open source, you benefit from the work of the community, so naturally you want to contribute back to the community. The fourth benefit is collaboration. Open source software provides a blueprint for collaborative software design. By its nature, open source contributions come from anyone who is benefiting from its use. And open source relies on continuous innovation and delivery of updates to the open source libraries. This requires solid communication within your company and with your partners outside of your company. The fifth benefit is control. By contributing to open source projects, the users of open source software drive the strategy, direction, and innovation of the project. If your company needs a new feature in an open source library you are using, you can develop it with iterative feedback from the other maintainers and contributors to the project, and then include it in the project for other consumers to use. You get the benefit of valuable feedback from the community, contributing to a higher quality version of your own application. And the community gets the benefit of the new feature of or functional improvement your company contributed to the project. In a way, using and contributing to open source projects provides companies with a way to control the destiny of the software they rely on to drive innovation and agility for their business. These are all great benefits, but the benefits don't come without some responsibility. Those responsibilities bring us to the topic of managing the open source software used by your developers in their applications. The fact of the matter is, even though your team didn't write the majority of the code in your application, that doesn't mean that it is not your responsibility to ensure that the components in your products are secure and compliant with your company's policies. In order to meet this responsibility, you need to establish a reliable inventory of all of the open source libraries used in your applications, both direct and transitive dependencies. You need to identify the known vulnerabilities of those libraries, and you need to make sure the open source libraries you are using are in compliance with your company's compliance policies. It is important to understand the rights and responsibilities defined by open source licenses. Open source licenses define rights such as the free distribution of the open source software, provide access to the source code of the open source software, allow for the creation of works derived from the open source software, and provide the right to use the open source software without limitation. When using open source software, all parties involved in the creation, management, and use of the open source code need a license so that the terms defining the distribution, the linking, the modification, the private use, right, and those types of things, all of those of the open source code can be automatically taken care of and readily understood. In other words, there's no negotiation needed between the maintainer of an open source project and the consumers of the open source project. There are many open source licenses to choose from, and each has its own terms of the above characteristics that even decide the ownership and credibility of the open source project. Licenses provide rules and guidelines for others to follow in order to use the work that you have contributed to the open source project. Open source licenses help others to contribute to your work or project without seeking special individual permission to do so. Open source licenses also define responsibilities for using the software. And a couple of examples include copyright and copyleft clauses. Most people are familiar with copyright protections. They protect your intellectual property from being copied or distributed without consent. Copyright protections in open source licenses may require any works derived from the licensed open source library to be published as open source projects themselves. Copyleft is the opposite of copyright. Copyleft ensures open source code can be copied and distributed. For example, a project that uses a strong copyleft license cannot be closed for copying or distribution. It must continue to allow copying and distribution of the derived product. So in other words, a license with a strong copyleft clause will require the user of the library with such a license to allow copying and distribution of any application or source code that they write that includes references to the licensed open source component. A second area around responsibilities is related to permissiveness. Permissiveness defines whether the licensed open source code can be mixed with other open source code. Strict licenses require the open source code to always be distributed with the license applied to the open source code by the original maintainer. It cannot be mixed, for example, with closed source or proprietary software, nor can it be combined with open source code with a more permissive license. Permissive licenses allow for the use of the open source code with other code assigned licenses of different strictness from the license assigned to the original open source code. In other words, the degree of permissiveness associated with a specific open source license is the baseline by which that open source license library with that license can be used. And if you want to include other libraries, other open source libraries with more permissive licenses, you may not be authorized to do so. That restriction may be enforced by the less permissive open source license. A third area of responsibility is around patents and royalties. Patent and royalty statements in open source licenses protect the open source code from attempts to patent the code as proprietary intellectual property of the publisher, right, who's the consumer of your open source code, or from attempts to charge royalties for the use of the open source code by consumers of your application. And this is especially true when the code is distributed in combination with proprietary code, right? Code that you wrote as part of the application. Some open source licenses may also predicate the use of the open source code on the restriction of the user's ability to sue the owner of the open source code. An attempt to sue the owner of the open source code that has such a license will result in the license being revoked, in which case you can no longer distribute your software that uses that open source library with that license. And a fourth area of responsibility is around linking. Linking defines whether or not you are permitted to incorporate your program into proprietary or non-open source programs. Restrictions on linking may prevent the use of your program or your application in a proprietary application, or they may explicitly allow for such linking. So it's important to look at the terms related to linking in any license associated with open source libraries you are using. Now, different licenses have different degrees of risk associated with these types of responsibilities. And as you can see in the slide, right, a couple of licenses, such as an example, GPL licenses, are very restrictive and include copyleft clauses. And as a result, they introduce a lot of risk. Other types of licenses, such as Apache 2.0, are very permissive and provide you the consumers of those libraries with those licenses with a lot of leeway in how they will use those open source libraries in their applications. So it's important to consider how the responsibilities defined in the characteristics of the license have an impact on risk to your company. When you don't manage these licenses in a proper and compliant way, open source licenses can expose companies to significant risk. Open source licenses have varying degrees of permissiveness or restrictiveness, as I defined on the last slide. Open source licenses may require your company to pay royalties to the maintainers of the open source project, comply with the copyright or copyleft protections defined in the license, or restrict or allow the publication of your own code as an open source project itself. Some open source licenses may impair your company's intellectual property rights to the part of the software you wrote when you use open source libraries associated with restrictive open source licenses. It's also important to confirm that the libraries you are using are in fact open source and have open source licenses. We have seen some occasions in the wild where a library is initially presented in an online repository as open source, but the reality, it turns out, is that the license associated with those libraries is a commercial license, and that can present some issues. So it's important to confirm that the libraries you are using that you believe are open source are actually licensed with open source licenses. Non-compliance with open source licenses can mean legal issues for your company, as illustrated in some of the headlines that are displayed on this slide. Non-compliance with open source licenses can lead to expensive fines. It can lead to a requirement to settle lawsuits out of court, which can be expensive and time-consuming. And it could potentially result in your company losing the rights to protect the code that you've written that's included in a project that includes open source licensed software. But compliance is not the only concern. Right? You are also responsible for managing the security of your code, which includes the open source code you choose to use in your applications. So let's talk about managing the security of open source software. There are some common security vulnerabilities we see very often in open source software today. The most common security vulnerability types include cross-site scripting vulnerabilities, which can expose your application to session hijacking, disclosure of sensitive data, or the forgery of user sessions. A second type of vulnerability we commonly see is information leak and disclosure vulnerabilities, which can cause an application to reveal sensitive data, such as technical details of the application itself, or the environment the application is running on, or potentially even user-specific data. Sensitive data can be used by an attacker to exploit the target application, the network on which the application is hosted, or the users of the application. A third common vulnerability type is input validation vulnerabilities, which can expose an application to an attacker submitting code to an application via an input field in a form, for example. This can result in an attacker being able to read or even delete data from a database table behind the application by submitting SQL queries from an input form on a web page, for example. So these are some of the common vulnerabilities we see. And as you can see, the problem of verifying that each and every open source component is secure and in compliance with your company's policy is becoming an increasingly complex proposition. And that's because information about open source components is scattered across hundreds of sources across the internet with varying levels of credibility. And most vulnerability databases accessible on the internet are not easily searchable. In addition, it can take a tremendous amount of manpower to do the research required to analyze the vulnerabilities and the license information of all of the open source libraries across all of your company's applications. In short, with the increased consumption of open source, the number of vulnerabilities and licenses you need to manage, it increases exponentially. And as the number of open source projects increases, right, the number of options you have available in the world of open source to potentially include in your application, and more applications use more open source software, that problem of management becomes much more chaotic. Well, why is that? In recent years, we've seen a spike in the number of reported open source vulnerabilities as awareness of the vulnerabilities rises. With more people using open source components, more eyes on those open source components, more vulnerabilities are discovered and subsequently published. There's also the fact that as an open source project matures, the average number of transitive dependencies across those open source projects also rises, right? Open source projects end up becoming consumers of other open source projects. And then when you make a direct call, create a direct dependency on an open source library you choose to use for the features you want in your application, you are also taking on the dependencies that that project has taken on as direct dependencies. And those subsequent dependencies become your transitive dependencies. So you're increasing the number of open source libraries in use in your application through that method. And the result of that is that developers may not be aware of all of the open source libraries used by their applications or the security vulnerabilities in those libraries. Also, the time it takes for bad actors to start attempting to exploit a known vulnerability in an open source library in your code is shrinking. That means you have less time to fix the vulnerability before you may become a victim of an exploit. This is because the attackers use the same security advisories used by the consumers of open source software to become aware of newly published security vulnerabilities. So both good and bad actors get the vulnerability information at essentially the same time. And then it's a race against the clock to see if the developers can fix vulnerable open source libraries before the attackers can exploit those vulnerabilities. So how do these risks of security vulnerabilities impact business? By their nature, defects in the open source libraries you use will equate to defects in your application. A couple of known vulnerability examples are Heartbleed and Shell Shock. These are well-publicized security vulnerabilities over the last few years. Heartbleed is a vulnerability in OpenSSL that allows an attacker to access data in the memory of a server. Shell Shock is a vulnerability in Bash that allows an attacker to escalate their privileges and execute commands on a server with that vulnerability. Both of these open source vulnerabilities expose your application to access of sensitive data that's exposed by your application or can make your application unavailable to users. Those are both significant risks that can impact the ability of your applications to generate revenue and meet business demand and serve your customers. And that can have a negative impact on your company's reputation. These security vulnerabilities can also put your company at risk of inadvertently exposing sensitive or regulated data, which can result in regulatory consequences, including fines or other issues. Security vulnerabilities can also put your company at risk of your services becoming unavailable or their performance being degraded, which makes them effectively unusable by your users. When your services are unavailable, that can impede your company's ability to run its business, such as processing orders, right? Or it can impede the ability to provide the service to your customers that they rely on. In spite of the risks of using open source software, there is still a lot of benefit to businesses that use it, as long as they manage it well. Automating the management of open source security and compliance provides businesses with the opportunity to take advantage of those benefits. So how can you get the control you need over the open source software used in your applications? Well, it all starts with establishing an inventory of all of the open source software used in your application. That includes both the direct and transitive open source dependencies. With this information, you can get a clear picture of the open source licenses and vulnerabilities associated with the open source components in your inventory. And with that, we can start to automate the management of open source compliance, security, and risk. So there are a couple of different ways that you can choose to manage open source. Many companies try to manage open source manually, but that ultimately results in your development teams having to manually track the usage of open source software in spreadsheets, or to request approval to use open source libraries via email. And these efforts will only slow down your developers, forcing them to spend precious time documenting their use of open source instead of writing code. Also, that manual method is prone to human error. You can do nothing and hope for the best, but then of course you remain exposed to security and compliance risk. Right? Just because you're not aware of the security and compliance risk, because you're not looking at it, doesn't mean it's not there. Finally, you can choose to automate all the processes related to your open source management, and let your developers focus on actually building new products and new features. Before we dive into the power of automation, I want to give you a brief snapshot of what life is like without open source software management automation. Here is the results of scans of 250 applications that Whitesource executed as part of POCs we've done with our customers. When presented with a comprehensive bill of materials of their open source libraries across all of their applications, most of the customers we worked with were only aware of 50% of the open source software they were using. In most cases, the evaluators we were working with were aware of their direct dependencies, but their biggest blind spot was the transitive dependencies in their code, which are far harder to track. In a computer program, a direct dependency is functionality exported by the library that is referenced directly by the program itself. It's a direct call to that open source dependency. But a transitive dependency is any dependency that's induced by the components that the program references directly. So in other words, transitive dependencies are called directly by your developers knowingly. Transitive dependencies end up becoming part of their projects passively by a reliance on the direct dependencies on those other dependencies. Right? So you can see how it can become difficult to be aware. Okay. Almost 90% of the applications that we scanned were vulnerable to at least one vulnerability. And 45% of them had 5 or more vulnerabilities. Our evaluators reported that they were constantly having communication issues between their R&D teams, their security teams, and their development teams. For example, when a security analyst would take product vulnerability data from one of their security vulnerability scans to a developer, it would be difficult for the security analyst to provide evidence of the vulnerabilities to the developer, and even harder to tell the developer where specifically in their code the vulnerability is invoked. And finally, evaluators were also reported, on average, open source libraries were in use that had at least one license that didn't meet their corporate compliance policies. The one license was generally associated with more than one library, so the impact was broadly spread. Automated open source software management is really more than just ensuring the security of your open source usage. The promise of automated open source software management is that it will help you to build better software faster by consuming open source without restriction or hesitation and without negatively impacting the agility of your development teams or the compliance of the software that you write. And providing automated open source software management throughout the software development lifecycle can help you to address potential security and compliance issues much earlier in the SDLC process, when it's less expensive to fix problems and provides the biggest and most positive impact on your security and compliance exposure. Automated open source management should make developers' lives easier when they're relying on the open source components that they choose to use. It should support pre-build stages of the SDLC to help developers find and fix vulnerabilities and compliance issues early on in the process. Automated open source management should also support security and compliance professionals. Right? It should support the build and post-build stages of the SDLC to provide managers, security analysts, auditors, and other stakeholders with full visibility and control over the risk associated with the open source usage in their organization. Now, at the planning phase, developers need to understand the vulnerabilities that are present in the open source libraries they are considering using in their projects. Right? Developers will use their web browsers to go to NuGet.org or Maven Central or RubyGems or any other online repository to research different types of open source projects that are available for them to use to provide features in their applications. Developers should be able to receive license and vulnerability information about the open source components they are looking at when they're investigating them and researching them directly in their web browsers. They can make better decisions about whether or not they should use a specific library or a specific version of a library if we can present to them in a pop-up in their browser information about security vulnerabilities or license risk associated with the library that they're looking at. At the code stage, developers should get information they can use to remediate security and compliance issues in the IDEs they use to write code. For example, a developer using Eclipse to build their code should be able to see directly in Eclipse that an open source library their code is dependent on has a security vulnerability, right? And that should be true whether the vulnerability is introduced by a direct or a transitive dependency. They should also be able to see suggested fixes to remediate the vulnerabilities, such as a suggestion to upgrade to a specific non-vulnerable and stable version of the open source dependency introducing a vulnerability. This will make it very easy for a developer to identify and remediate potential security issues with a vulnerable library before their code gets to the build stage of the SDLC. Once the code is built, it often is pushed to an online repo, such as GitHub or Bitbucket. In these cases, it's also possible to trigger scans of the code in these repos on every single commit, and then identify the open source licenses associated with libraries in that repo and security vulnerabilities for the open source components referenced in the committed code. This can all happen before you try to run a build pipeline job. We should also be able to create issues in your online repo for any vulnerabilities identified with open source libraries in the repo. And then make it easier to track the presence of the vulnerability and the subsequent remediation of the vulnerability. And we can also automatically create pull requests to change the vulnerable direct dependencies to stable non-vulnerable versions in an automated way, essentially updating the library to a stable non-vulnerable version without the developer having to manually create a pull request. And that activity can save developers a lot of time by automating common security and compliance tasks, directly inside of the code repos. At the build stage of the SDLC, you should be scanning your code in line with your build pipelines to identify potential issues in the code repos used in your build tasks, in your pipelines. You may even want to fail a build if it does not comply with corporate license or security policies. Right? And incorporating open source scanning as a part of your build pipeline can make it possible for you to proactively prevent security or compliance issues from getting into compiled applications and code that get published to production. And finally, during the deploy stage and the maintenance stage, you can scan your built applications and also the containers on which the applications are run if you're deploying in a containerized environment. And that can provide you with a comprehensive view of the risk of all the open source libraries used to run your applications, not just the ones in your code, but also the open source libraries on the containers that are running your code. And finally, at the maintenance stage, teams need real-time alerts about new security vulnerabilities that are discovered after you've run your scans, right? Those new vulnerabilities are published every single day and may impact open source libraries that are already used by your team's applications and are already in your open source inventories. New security vulnerability notifications are published every day, and you need to get alerted if they impact a library you're already using. It is also important to understand if your code is actually exposing a vulnerable method in an open source library that could make that vulnerability exploitable. And that is where vulnerability prioritization comes into play. Now, throughout the software development lifecycle, it is important to use your development and security analysis resources efficiently. If you don't, your teams may waste time focusing remediation efforts on vulnerabilities your code is not really exposing, while other vulnerabilities that are effectively exposed in your applications go unchecked. Now, if all security vulnerability alerts are pushed to software development teams, those development teams may drown in potentially hundreds of alerts. They can't possibly respond to all of them. As a result, prioritization of remediation activities becomes critical to the efficient and agile work of your development teams. Companies need to prioritize vulnerability remediation efforts according to their impact on the applications. This can be done by using open source scanning tools to create a call graph showing whether your proprietary code is making calls to vulnerable methods in open source libraries, which would make those vulnerabilities effective and exploitable. If your proprietary code is not making calls to specific vulnerable methods in some of your open source libraries, then those vulnerabilities are considered ineffective and cannot be exploited. Remediation efforts on those vulnerabilities can be deprioritized. Our research shows that up to 85% of the vulnerabilities in Java applications are ineffective, which means that the remediation of the vast majority of vulnerabilities can be deprioritized. And then remediation efforts can focus on the 15% of the vulnerabilities that are actually effective and actually exploitable and definitely directly impact your applications. And just to reiterate, it's important to keep in mind that open source libraries are used in containers and serverless functions as well, not just in your own source code. So your open source management processes should include your container registries and container management tools, as well as serverless functions that you might develop, such as AWS Lambda functions, so that you can effectively manage the risk and compliance of the open source libraries in these images, containers, and services. Many times these containers and services come with open source libraries in them that you did not explicitly choose to include in them. These libraries come from the base images your developers have selected from an open source container registry such as Docker Hub. Still, you need awareness of these open source components, their licenses, and their vulnerabilities, even though they were placed in the original image by the maintainer of the image and not by somebody that works in your company. Now, in summary, when you are considering approaches to automate the management of open source libraries, be sure to consider these 3 key areas. The first one is completeness. Your open source management approach should offer a one-stop shop to manage all of your open source libraries, regardless of environment or language, and regardless of whether they're direct or transitive dependencies. It should also service the needs of all constituents in your company that need security and compliance and risk data about your use of open source, including security teams, development teams, DevOps teams, legal teams, compliance teams, and even business management. The second area is prioritization. Make sure the approach you choose does not trigger alerts on false positive findings, which can waste precious time researching problems that are not really problems. Also, make sure the approach supports your efforts to prioritize the remediation of vulnerabilities based on their effectiveness and their risk of exploitability in your application, and whether or not you are susceptible to those vulnerabilities. And the third area is around remediation. Your open source management approach should not only alert you on issues, it should also help automate the remediation of issues by generating automated pull requests, offering validated suggestions for fixes, and initiating automated workflows, all of which can save developers time trying to deal with identified security vulnerabilities or compliance issues. And with that, we thank you for your time. I'm happy to take some questions at this point. Wilson?
Yes, hi Jason. Let me see here. So we have 2 questions till now. The first one is, how does Whitesource differ from a code quality check? Please.
That is a good question. So code quality checks tend to look at the code that you have written and provide sort of a subjective look at whether or not the quality of the code meets certain criteria. If it has common references that are known to potentially introduce vulnerabilities. But what Whitesource does is provide confirmable, 100% reliable, known references to known vulnerabilities in the open source projects that are actually used in your application. The methods that we use to match the open source libraries that we scan inside of your code leverage checksums which are verifiable. If we find a match between a checksum of a library in your application we have scanned to a library in our inventory of open source libraries from across all the repositories available on the internet, then we know those 2 libraries are exactly the same. So we can tell you with 100% certainty that those libraries are using a specific open source license that may or may not introduce risk, and that those libraries do or do not have security vulnerabilities that are known to be applicable to those libraries. So it reduces the risk of false positives and helps you to have a much more confidence that you are measuring the actual impact of security and risk in your use of open source. Not only that, but using a tool like Whitesource to scan for open source compliance and risk and security issues is a bigger bang for your buck compared to a code quality checking tool, because up to 85% of your code is comprised of open source. So the bigger impact on the security and risk posture of your application comes from reliably identifying security and risk issues associated with your open source code, not the code that you've actually written.
Great, great. So the next one is, how does Whitesource manage vulnerabilities? Is there a central repo that Whitesource fetches vulnerabilities from?
There isn't one central repo. The most commonly referred to repo of open source libraries and their security issues is the National Vulnerability Database managed by MITRE. But with Whitesource, we use machine learning algorithms to automatically scan not just the NVD, but also over 20 other security advisory services in order to get information from a broad set of security advisories available on the internet about open source libraries and their security. Not only that, Whitesource employs a security and compliance research team. So that team does two things. One, they validate any new security vulnerability advisory we receive as part of our machine learning algorithms to confirm that it's a real vulnerability before we publish it in our database. So there's extra reliance or extra confirmation of the vulnerability being a real vulnerability that actually impacts a specific open source library. And also our research team executes their own research of security vulnerabilities. So our team periodically will identify a security vulnerability in an open source project before the maintainers of that project may even be aware of it. We also, Whitesource just recently became a CVE numbering authority for MITRE, which means that we now have the opportunity to promote for publication any vulnerability our security and research team identifies as a confirmed vulnerability to be published in the NVD. So it's really not just a one-stop shop, right? We're trying to take information from as many sources as we can about security vulnerabilities that impact open source libraries. And we want to consolidate that information and verify that it's real information so that the analysis you receive through our product is reliable.
Okay, so there is no more questions. Please, next slide. I speak in Portuguese, then I come back. Sure. Obrigado, pessoal, pela participação. Aqui está o contato da Nova 8 e nós também vamos enviar via e-mail, né, o link para vocês assistirem o vídeo da apresentação, também os slides, anexo, os slides da apresentação, e esse link onde a gente está apresentando essa ferramenta de autoavaliação. Ela é composta de 17 perguntas que irão ajudá-los a avaliar o risco de open source na sua empresa, ok? So Jason, thanks so much for your great webinar.
Thank you, Wilson. It's been a pleasure to present everyone, and we look forward to being in touch in the not too distant future.
Thank you.
Happy holidays.
Yep, thank you. Em nome da Nova 8 e Whitesource, agradeço a atenção de todos e tenham um bom almoço e boa tarde. Obrigado.